which one you wanna discuss more detail in the 6 questions, because normally we cannot finish everything in the one tutorial. So if you have any preference with a question that I need to discuss in this session, just let me know and I will try to discuss your preference question. If not, we will do in order, starting from 1 until 6, and finish at 5 to 7, 5 to 5. Sorry. Question 3 and 4. We start first by question 3 and 4. Okay, so this is an inclined manometer where it's filled with oil of specific gravity 0.85. The cistern is initially open to the atmosphere, so everything is open to atmosphere, so it should be in the same level from the beginning. A pressure line is then connected that gives a kick pressure of 500 Pascal. So we already have information that this line will be connected to 500 Pascal. And the oil surface in the manometer tube is displaced by the distance of 200 millimeters. So this is the distance. So by the time there is kick pressure that is higher than the atmosphere, and suddenly it increases 100 millimeters. The distance is in the diagonal, not in the vertical one. Okay. And we need to define the manometer angles. It's already defined that the angle is 2.85, so we will discuss. First, the problem is about the classic inclined manometers. So it can be used to measure the small pressure difference. So this is the initial conditions. We have this dark line. It's the initial original condition. And then suddenly there is incoming of the pressures. There is displacement delta H. This is the pressure. I think the same will be equal to A. And then the increasing from the gas line to the location is denoted by lowercase h. It will is equal to 200 millimeters or 20 centimeters. Okay. First, we can discuss in. Okay, sorry. I think I can use the also. The dash line show the original location for the top of the fluid in the chamber and the inclined line. So this is the original one. And then the input. So the pressure P, this is the location of P, will be equal to rho T and H, where the H is. Okay, this is the kick pressure at B. And we change the H with the relation with T, so we can change that H equal to T multiplied by sinus alpha. And then the next is from the pressure at P, we can go to pressure C. We have vertical line here between P and C, where the distance is equal to delta H. Please be reminded that this is H and this is delta. So it's different. It is for the pressure from this point to this point, and this one is to calculate the pressure at level C based on the pressure at P. And the pressure at C will be equal to pressure P plus, because it's in the downward directions, will be equal to rho T and delta H, because the distance between P and C is delta. If we sign in everything, we will have pressure at C equal to rho T T in H plus rho T delta H. Since the liquid or oil is incompressible, thus the fluid will move into the side pipe equal to the fluid loss from the chamber. So this is the one that we can make a relations how to calculate the changing of volume. The volume movement from this is the incompressible flow. So if there is displacement from this line, from this dot line to the level C, so there is volume radius, the volume changing, will be equal to the volume increasing in this area. So A is the cross-sectional area multiplied by the delta H. This is the thickness will be equal to the lowercase. This is the cross-sectional area for small pipe multiplied by, even though there is any small inclination, we can neglect this one because this is very small area. So we have delta H will be equal to over A divided by A per E. And A per A, we will discuss in, okay, so in this case, we have A. Not focus. So because we have informations that A, the diameter A is 5 millimeter, and capital A has diameter of 1 centimeters. Okay, so the ratio between A per A equal to P per 4 5 millimeter square divided by P per 4 10 millimeter square. Okay, it's gonna be half 100 to 1. Okay, this is additional information that we can have in this calculation. And then we back to the questions. We input the process C and we change the delta X here, which is A per A G. So we can get the default rho G and A per A is 1 per. And then if we substitute to the equations, well, the pressure at C, yeah, pressure at C1 is connected to the source pressure. It will be equal to 500 Pascal. And then density is 850 kilogram per meter cubic. This is the gravity is 9.81. And then G equal to 0.2 meters because the displacement is 20 centimeters. And A per capital A is a quarter. Sorry for this miscalculation, so I will write in my we have DC equal to rho G. So this is 500 in So we have the final. Sorry, this is the focus. Not working. Okay, I think it's better. So this is the final. In the final equations, we have the PC is OGT multiplied by sin alpha plus a per capital. So derive the equations, we get the alpha with 2 input of sins of 0.049814 that equal to 2.85 degree. Okay, any question for number 3?
Can you just go back to the slide with all the work?
In the slide? Yeah, in the blackboard. This will be available on your blackboard. Okay. The next, my friend, Taulu, are you ready for the next? Oh, okay, yeah, that's okay. The next is question number 5. Okay. Okay, so this is the question number 5. The dam ABC. So this is the construction of the dam. In figure 5 is 40 meter wide. So the meaning is if it has the wide like perpendicular to your in our direction is 40 meter into the paper and made of the concrete between 22 kilo Newton per meter cubic. Assuming that the density of water is 1,000 kilogram per meter cubic, we need to calculate the pressure force on surface AB, where the atmospheric pressure is 100 kilo Pascal or 1 bar. Okay. So to solve this problem, so we have construction like this one. This is the constructions. So so I make in one 3D. So this is 80 meters. This is 60 meters. So using the Pythagoras, it's gonna be 100 meter. Okay. And the width to the paper is defined at 40 meters. So this is the constructions. And to find the pressure force on surface AP, so we know that there is a force over here due to the water and air. So how to graph it? See, there is force that they have a higher and higher force based on the hydrostatic formula. We know that by increasing the gap from the water surface go down, we have the higher hydrostatic pressures. So we also have the higher force to the dams. and also there is pressure coming from the air. Okay. We know that atmospheric pressure will be always perpendicular to our surface. So if you have balloon, the pressure will be not only from top, but also from the side, also from the bottoms and anything. So they have perpendicular to any surface. But for the hydrostatic, it's also the similar, but depend on your elevation or your depth from the water surface. So to make it simple, first we know this is the uniform force. The atmosphere is uniform. So we assume that the atmospheric pressure at the level 0 until 100 is going to be constant. So there is no change of the atmospheric pressure, but the change is only happen on the hydrostatic force. So to make it simple, first we can use the center of gravity systems, and the second we can make manually integral the equation. So for the center of gravity systems, we can change the linear force of the hydrostatic with one single force. So we can change with single force. This is force at center of gravity. Okay, center gravity. And the height of the center gravity, because this is rectangular on this area, it's gonna be half of the depth. So this is so 80 is the total depth, and the center of gravity is the half of the depth. So we can go back to this and input to our equations where the force is equal to the force coming from the atmosphere plus the hydrostatic, where the location not on the bottom, not on the top, but on the location where the center of gravity. So we cannot use x, c. And area is 100 multiplied by 40. Okay. And we come with what is the pressure at the center of gravity. This is the center of the atmospheric, and it's the pressure in this area where it can be used to change the uniform pressures coming from top to the bottom with one single pressure that on the center of gravity with at the height of the center of gravity that is half of it. So this is the pressure at the center of gravity. Because force is pressure multiplied by area, so we only multiply we can multiply this pressure with area, that is 100, because this is diagonal 100, and 40 is not the center, but the width of our dam. So it will be equal to 2 giganewton. Yeah. And yes, sorry. This is sorry. Yeah, this is equal. So because wait, I will make we will show it on the integral equation in the next year, but I will make here. So if you take on in this case, we have here the presentation of the force this is point B, and this is point A, for example. This is in the area A to area B. We can change all of this force with the single one that is equal to center of gravity. This is a function of h, and this is the single one. It's quite, I don't know how to explain this one, but maybe the next step, so I will show in this next step, is gonna be easier for you to understand from the perspective of integral, because we will integral one by one of this question, so you can feel how this one, how the previous one can be replaced by the single pressure. So there are another way that I will explain in these calculations is the pressure gradient force or the atmospheric force on surface area is the result of what water and air, and for the water part, it could be divided into horizontal and vertical components. Okay. So we have two model to solve. Okay, this is the method one. This is the method two. The total pressure, the total force will be equal to force coming from air plus force coming from water. Okay. And for the air, it's gonna be easy because force from air will be equal to the atmosphere multiplied by A. But force from water, there are two resultant force, horizontal and vertical one, because there is hydrostatic and there is weight of mass air. So we have two representation is force horizontal water plus force vertical water. The meaning vertical, sorry, I will start with the vertical one because this is easier to understand. So this is the construction of a dam. C, A, B, and this is the water. Water is so this is mass of water, where it is A, B. For example, this is D. This is water. Because of gravitational force, it's gonna be F vertical weight. This is weight of water. This is for the vertical force. And for the horizontal force, this is coming from the hydrostatic, where we can calculate, sorry, this is vertical, and the horizontal is coming, for example, sorry, we have line A to B. For example, just assume this is the projections AP, and we make projection GP, yeah, because this is in one vertical line, so we can make AP, where the pressure is flat as function of y. Okay. it make, if we take integral, it's going to be similar with the center of the gravity. So if we back to slide. So for the horizontal force that is coming because of the hydrostatic in the depth of the water. So we can take integral. This force is P multiplied by GA, where P is rho G H. Because we have information that the pressure is varying in its directions, but constant in with y here.
So the DA, would you use AB or C?
Sorry?
For the DA, would you, I know you use the, how it drops into, how do you, which one do you use? Do you use
This is the W is the weight of to the page.
yeah, which one page? So do you just use it?
Yes. TH. Yes, using H. That is zero again.
That's your DA.
Yeah, TH. Because they must be in the vertical, not in the inclined, because we have the similar on the vertical lines.
Okay, and you take that all with H.
Yeah. So I will make integral here.
Yeah, the width time in H.
So let me explain. I think it's better. Okay. We have yes.
So is that a general rule that you use the width times the infinite point behind?
So in a point
The tiny point behind.
Yeah, if we take, because this is the actually this is coming from P equal to rho T rho G T. Okay, the small pressures, the changing of the small pressure equal to rho G T. So if we take as the function of H, we know that A G A is equal to sorry, this is rho G8 okay, W G H E. Okay, we have still that pressure equal to density, gravity, and H, and dA, the small area, will be equal to W multiplied T. Okay, and P is the function of H. Okay, in the mathematical. So if we input to these equations, so G H, so G H. Actually, this is W G H. Or integral rho G X W G H. Okay, so we back to this definitions. Okay, after we have the formula, because it is the function of X, so we have W rho and G are fully constant, so we can take it out from this in the formula. Constant, this is function of the X, and this is also constant. So actually three of these variables can go out from the integral. So we have for P, rho, G, and because of the integral it's dx. And take integral from 0 until its total is 80 meters. And the vertical, because the vertical is the mass that we already discussed before, this is the prism mass of water above this dam construction. So total force is going to be mass multiplied by gravity. So mass is density multiplied by the gravity. And the volume is the weight is 40. And this is the prism. 80 multiplied by 80 multiplied by 60 divided by 2 because this is 3 angels. Not the dam construction, but the water. You see from the water perspective. So we're taking out this volume. We calculate this blue water volume. Sorry. We have this calculation. And the force coming from the air, we already discussed before that this coming from atmospheric pressure that's multiplied by area. And again, the area is 40 multiplied by 100. 40 is the width in this in total, we have that the total force is force coming from air plus from force coming water. I think it's easier to explain than the previous one because the first one is directly to center of the gravity, because center of gravity is a lot of equation that I need to explain, but I think this one is much better to understand how we calculate, because if we not read in the total definition of the center of the gravity is gonna be quite difficult, yeah, to but this case I think it's easier. I hope it's easier. So we have the total force is air plus the water, because the water is two components. So we have the resultants in the angle of 90 degrees. So we have the resultant is on this form. And again, we have the similar results. Either we calculate using the center of gravity or calculate by derive one by one force coming to the dam, that is coming from air and coming from water. The same thing actually you will have on number 6, the discussion. We also have two different approach to finish the solution, where we can also calculate based on the center of the gravity using the single pressure on the center of the gravity, or you are integrating one by one using integral formula. Maybe I will discuss number 6 to make it clear for number 5, because it's quite related. Before we move to number 6, is there any questions? No? Okay, this is question number 6. We have the hydrostatic force, but we need to find the hydrostatic force per unit width on the rectangular plate. It is 80. This is the same. We have but not defining what is the W, so we need to find force per weight area, or F per W. In this case, we have the location of it is 3 meters below the water surface, and the depth from it is 2 meters. Because this is the construction is the rectangular, so we know that the center of gravity is going to be in the mid of 2 meters. Okay, so we Also, we have water surface. We have the construction. This is 3 meter. This is A. This is B. And so on. We have 2 meters. Because we know the center of centroid is on this line. So this is 3 plus 2, 3, 2, 4 meters. So this is the height of center chamber. We have sorry, we have 3, and then half of 2 divided by 2. We have 4 meters. And back to question. So we have force will be equal to pressure multiplied by area. And the pressure will be equal to density multiplied by gravity multiplied by depth on the center of the gravity. So apakah misalnya 4 this is 9.81. So we have 39,250 kilonewton per meter square or kilo pascal. And the area itself is 2 meters and per with area. So this is 2 meters per width. So we have 80 kilonewton per meter. The same things with the other methods when we only calculate the gate pressures. Why we not calculate the air pressure on this case? Because in the previous one, we calculate surface AB. In the previous one, we have in case 4. We need to calculate the air because AB not in the one line, they only exposed to absolute the pressure, and the other line they are not exposed to atmospheric pressure. But on case number 6, we know that if we calculate the atmospheric air coming from top, we need to cancel force coming from left side. So we only need to calculate the kick pressures. Okay. So if we say like this one. Okay. This is area AP. AP, where the pressure is already here. Oh, sorry. By the depth, they will increase, but not starting from 0, because this already have initial depth. In absolute, if we take absolute ports, absolute pressure. Absolute pressure case, from the left, we have P atmosphere plus P hydrostatic. On the right, we also have force coming from atmosphere. That the direction always perpendicular or always towards to our surface, because the AP is supposed to the other atmospheric pressure. So to make simplification in the balance, because we have one to the from the left, we have one to the right, and from the left we have atmospheric to the left, so we can cancel the atmospheric pressure and we are needed to calculate the hydrostatic pressure. The hydrostatic pressure is equal to kick pressure, because this is the increasing pressure from the atmospheric level. Because the gap is completely submerged. And continue with the equation, which is force per unit weight. So this is F per W, because we again E is rho GH and GA equal to WGH, and the force is per unit weight, so we can cancel the weights and get this formula where density and gravity is constant 2h. So the integral is coming for variable. We have x1.2 and the g is constant. And this we remind that the integral not coming from 0 to 5, but coming from 2 to 3, because we only calculate the pressure on surface 18. So from 3 to 5. So that's coming from 1 to 5, so coming from 3 to 5. And the result is the same with the calculation using center of gravity. Okay. Any questions? Okay. Okay, if no questions, because we already 10 minutes to 5, we need to end this discussions. So if you have any questions, that is online Q&A in Piazza, or you can email to Alistair, and we will try to answer your question. Thank you, and see you next week. Yeah. Oh no, that's fine. Yeah. That's good. Yeah. Oh, yeah. Okay, that's fine. Okay, I know everything.
Yeah. Have a good weekend.
Yeah. Yeah.